Ton 618 should not exist at this size, not because the math is wrong, not because the observation is flawed, but because there is a physical ceiling, a hard limit baked into the laws of the universe, and Ton 618 appears to be sitting right at it or past it. Two peer-reviewed studies, two different methods, two different masses. One of them may be wrong, but here is the problem. Even the lower number still challenges the physics, and the higher number does not just challenge it, it breaks it. That is where this story starts. In 1957, a team of astronomers at the Tonantzintla Observatory in Mexico was cataloging faint blue objects scattered away from the plane of the Milky Way, mostly white dwarfs, the burned-out cores of dead stars. Entry number 618 in their catalog was logged as something similar, a faint violet smudge on a photographic plate. Quiet, unremarkable. It did not glow in radio frequencies. It did not have a visible host galaxy. To every instrument available at the time, it looked like a nearby, ordinary dead star. It was not a nearby dead star. That mismatch, 13 years of misidentification, filed and forgotten, is the first detail that matters. Not because anyone suppressed it, because the object was so far outside the known catalog of possibilities that the correct answer simply did not occur to anyone. For 13 years, entry 618 sat in the files. Then, in 1970, a radio survey in Bologna, Italy, swept the same patch of sky and found something that did not match. The object was emitting radio waves at a scale white dwarfs are physically incapable of producing. When astronomers measured its redshift, the degree to which the light had been stretched during its journey across an expanding universe, the answer came back wrong in the best possible way. This was not a nearby object at all. The light from entry 618 had been traveling for 10.8 billion years. When that light left its source, the universe was barely 3 billion years old. Earth did not exist. The solar system did not exist. Nothing about our corner of space had yet formed in any recognizable shape. What they had spent 13 years ignoring was the ancient signal of one of the most violent objects in the known universe: a quasar. A quasar is what happens when a supermassive black hole feeds at extreme rates. Gas and dust from the surrounding galaxy spiral inward toward the event horizon, compressing under enormous gravity, heating to tens of millions of degrees, releasing energy as radiation so intense it can outshine an entire galaxy. And here is what makes Ton 618 exceptional within that already extreme category. From 10.8 billion light-years away, the galaxy hosting this quasar is completely invisible, swamped. The quasar alone, driven by a single black hole, was bright enough to register on photographic plates with a modest 0.7-meter telescope. The surrounding galaxy, containing hundreds of billions of stars, simply disappears into the glare. Ton 618 shines with the luminosity of 140 trillion suns. Not stars in general, 140 trillion of our own sun. In its active phase, this single object likely outshone galaxy clusters. And at its center, driving all of that energy, is the most massive black hole currently known to science. The mass estimate, and this is exactly where the story opens, ranges between 40.7 and 66 billion times the mass of our Sun. Let that range settle before moving on. The black hole at the center of the Milky Way, Sagittarius A, weighs approximately 4 million solar masses. Ton 618 outweighs it by a factor of somewhere between 10,000 and 16,000. If you took every single star in the Milky Way and collapsed them entirely into one object, you would still fall short of Ton 618's upper estimate. The event horizon, the boundary from which nothing, not even light, escapes, stretches roughly 1,300 astronomical units in radius. 1 astronomical unit is the distance from Earth to the Sun. Pluto orbits at around 40 astronomical units. Place TON 618 at the center of our solar system, and you could travel past Pluto, past the Kuiper Belt, past the outermost edges of our planetary neighborhood, and still be less than 5% of the way to the event horizon's edge. This is the scale, and the scale is the problem. Not just the size of the object, the size of the contradiction it creates. The simple explanation for how TON 618 reached this size sounds entirely reasonable on first contact. Black holes grow by consuming material from their surroundings. The early universe was richer in gas, dense clouds of hydrogen left over from the Big Bang, not yet locked inside stars. Massive galaxy collisions can funnel enormous flows of gas toward the center, where the black hole feeds. Given enough time and enough fuel, a black hole grows large. That is the first version of this story. It is not wrong. It just stops working at exactly the mass where TON 618 lives. Here is why. There is a natural speed limit on how fast a black hole can eat. When material falls into the accretion disk and spirals inward, the compression and friction release radiation, powerful, outward-pushing radiation. At a specific threshold called the Eddington limit, that radiation pressure becomes strong enough to push new infalling material away before it can reach the event horizon. The black hole's own light turns against its appetite. TON 618's luminosity of 140 trillion suns tells us it was operating at or very near that ceiling. This was not slow, comfortable growth. It was maximum rate feeding, sustained against its own radiation over an enormous span of time. That is not impossible. But it means the simple explanation, it just ate a lot, was already under strain before anyone looked closely at the mass. Then the mass number arrived, and it did not arrive clean. 2 separate research teams analyzed TON 618 using spectroscopic techniques, studying the emission lines in the light of orbiting gas to infer the gravitational pull at the center, and from that, the mass. The Schemmer et al. Study, using CIV and NV emission lines, returned a figure of approximately 66 billion solar masses. The Guy et al. Study, using a different calibration of the same virial method, returned approximately 40.7 billion solar masses. Both papers are peer-reviewed. Both appear in scientific literature. The difference between them is 25 billion solar masses, which is itself larger than most of the other heaviest black holes ever measured. That is not a rounding error. That is a separate, unresolved question living inside the first one. We do not actually know, with confidence, which version of TON 618 we are measuring. The strange part is not which number is higher. The strange part is what both numbers are approaching. Astrophysicist Andrew King at the University of Leicester has described a theoretical ceiling for how massive an actively feeding black hole can grow. It is not an arbitrary rule. It emerges directly from the geometry of the accretion disk. Every black hole has what physicists call an innermost stable circular orbit, the ISCO, the closest point at which matter can maintain a stable orbit without being drawn inward. For a non-spinning black hole, King's calculations place the maximum mass at approximately 50 billion solar masses. Beyond that threshold, the disk's own self-gravity, the collective gravitational pull of all the material orbiting the black hole, overwhelms the pull from the black hole itself at the center. Matter can no longer be dragged inward. It loops around the event horizon, distorted but unswallowed. The delivery system stops working. The black hole can no longer eat from its own plate. Think of it this way. The accretion disk is not just food. It is the only mechanism by which food can be delivered. At extreme mass, that mechanism collapses under its own weight. The disk's material starts pulling on itself more strongly than the black hole pulls on it. The funnel breaks. And yet, TON 618, at 40.7 billion solar masses approaching that limit, or at 66 billion solar masses having crossed it, exists. At 40.7 billion solar masses, TON 618 is near the ceiling. At 66 billion, it has passed through it. Either way, the growth model hits a structural wall precisely where TON 618 lives, a black hole that somehow reached or exceeded the mass at which feeding becomes self-defeating. That is not a poetic way of describing something large. That is a specific physical contradiction inside the models used to explain black hole growth. So the question is no longer only how large TON 618 is. The question is how it got there at all, and whether the answer reveals something incomplete in the models or something about TON 618 itself that we cannot yet measure. There are three possible explanations. The first involves what we may be getting wrong. The second involves what we cannot see. And the third, the one physicists are handling with the most care, does not just change the story of TON 618. It changes what the universe's largest objects are heading toward and what happens when they arrive. None of them close the case cleanly. The first possibility is the one most people instinctively reach for. If the higher mass estimate, 66 billion solar masses, is wrong, then the problem shrinks. If the G. et al. Figure of 40.7 billion solar masses is closer to the truth, TON 618 approaches the ceiling without necessarily breaking through it. The measurement conflict is real. The two peer-reviewed methods genuinely disagree, and neither technique is without its limitations. Spectroscopic mass estimates for distant quasars rely on the virial method, measuring how fast gas is orbiting the black hole, then using that velocity to infer the central mass. But the gas in a quasar is not a clean, stable ring orbiting at a fixed distance. It is turbulent, heated, dynamic. The geometry of the broad line region, the zone of gas that produces the emission lines used in these measurements, is not fully understood. Different calibrations of the same underlying physics return different results. A factor of 2 uncertainty is not unusual. That is not a failure of science. That is science working honestly with objects it cannot directly resolve at 10.8 billion light-years of distance. But that honesty creates its own problem. If the uncertainty is factor of 2, and the lower estimate already sits at 40.7 billion solar masses, then the true mass could plausibly be anywhere in a wide band around that number. Some of that band still clears the ceiling. Some of it does not. The measurement conflict does not resolve the paradox. It makes the paradox harder to pin down. That is where the second possibility enters, and it is the one that feels, at first, like a solution. Black holes spin. Not all black holes spin at the same rate. A non-spinning black hole and a maximally spinning black hole behave differently in ways that matter for the ceiling. When a black hole rotates, the geometry of space-time around it changes. The innermost stable circular orbit, the ISCO, the gateway where accretion either succeeds or fails, moves closer to the event horizon. The disk can reach farther in, and the mass ceiling shifts upward. For a maximally spinning black hole, the theoretical limit is meaningfully higher than the 50 billion solar masses King calculated for a non-rotating case. If TON 618 is spinning rapidly, the ceiling rises. The paradox eases. The model survives. That should have closed the case. Except we cannot measure TON 618's spin. At 10.8 billion light-years, the resolution required to detect spin signatures in the accretion disk is beyond what current instruments can achieve. Spin is inferred from X-ray reflection features close to the event horizon, signals that require precision measurements of objects that are already invisible as individual galaxies from this distance. TON 618's spin is not an unknown that scientists are working to pin down with the next telescope. It is an unknown that current physics may be unable to close from Earth at all with any instrument presently envisioned. The most physically plausible escape hatch is the one we cannot open. That single gap, the unmeasured spin, sits at the center of every version of this story. It is what separates TON 618 is a puzzle from TON 618 is a paradox. A spinning black hole and a non-spinning black hole of the same mass are observationally almost identical from this distance. We cannot see the difference, and the difference is the only thing that might explain how the ceiling was crossed. This is where the strongest version of the explanation has to be stated carefully. The most likely answer, not confirmed but most consistent with what the models allow, is that TON 618 grew through a combination of mechanisms: rapid spin, which shifted the ceiling; extraordinary early universe conditions, when gas densities were high enough to sustain maximum rate feeding before the self-gravity problem became fatal; possibly galaxy mergers, which could funnel material at rates that briefly exceeded normal accretion limits. Not one cause. Several operating together across billions of years of cosmic time. That version of the story does not break physics. It stretches it. But it leaves a problem. It depends on a spin we cannot measure, an early accretion history we cannot reconstruct, and a mass estimate that spans a 25 billion solar mass range of uncertainty. The strongest explanation accounts for the general shape of the paradox. It does not close the specific details, and science does not progress by accepting general shapes. It progresses by closing specific details. The specific details are not yet closed. And that is when the fourth version of the story becomes the one that stays with you longest. If black holes can reach a mass at which their own accretion disk can no longer feed them, if the delivery system eventually collapses under its own weight, then what happens next? The answer, according to the physics, is that the black hole goes dark. Not explosively, not visibly. It simply stops glowing. The accretion disk thins, stalls, or disperses. The radiation that made the quasar luminous disappears, and the black hole itself becomes invisible, not because it ceases to exist, but because without an active disk, there is nothing nearby hot enough to emit detectable light. Without an accretion disk, a black hole is essentially unobservable from cosmological distances. Astrophysicist Becky Smethurst at the University of Oxford has described this implication directly. Quasars will wink out. The universe's largest black holes may already be past the point where they can feed, and when they cross that threshold, they vanish from our catalogs. Not metaphorically, observationally, which raises a question the data cannot currently answer. If there are black holes that have already passed the ceiling and gone dark, we have no way to find them. We have no way to count them. We have no way to know whether TON 618 is the most massive black hole in the observable universe, or simply the most massive one still glowing. There could be objects more massive than TON 618 drifting through the dark right now, past their feeding limit, generating no light, emitting no signal, present but invisible. If the universe's largest black holes have been going dark for billions of years already, then the night sky we are mapping, the catalog we are building from every telescope pointed outward, is not a complete record of what exists. It is a record of what is still lit. The rest has already gone quiet. Now place yourself in the position of whoever is looking at that data tonight. The telescopes that observe TON 6118 are not watching something happen in real time. The light arriving at the detector right now left its source 10.8 billion years ago. The quasar recorded in our instruments is a snapshot, not of what TON 618 is, but of what it was, when the universe was 3 billion years old and the solar system was still billions of years from forming. We have no observation of TON 618 as it exists today. We have no way to get one. The signal traveling toward Earth right now left TON 618 when the dinosaurs had not yet evolved, when the continents were in entirely different positions, when nothing about the current state of the universe resembled what exists today. That signal will arrive in roughly 10.8 billion years. By the time it does, nothing on Earth will be watching for it. What we have is a message, not a presence, a record of something that existed in a particular state, at a particular moment in the universe's early history, under conditions that no longer exist anywhere near us. The machine may already be off. The quasar may have already gone dark. The enormous disk of superheated gas that made TON 618 detectable from 10.8 billion light-years away may have stalled and dispersed billions of years ago, leaving behind a black hole of extraordinary mass, sitting in the center of a now quiet galaxy, silent and invisible in the present universe. We are reading old mail from something that may no longer exist in any recognizable form. And here is the part that closes this the wrong way, if you are hoping for certainty. The story does not end at a conclusion. It ends at a shape. TON 618 is at or near the ceiling. The ceiling is real. The mass is uncertain. The spin is unmeasurable. The growth history is reconstructed, not observed. The current state is unknown. And somewhere in the dark, there may be objects even larger, already past the threshold, already silent, already gone from every catalog we will ever be able to build. There is a photographic plate, taken in 1957, at a modest observatory in Mexico, a faint violet smudge. Entry 6118. It was filed as a white dwarf. It sat in the catalog for 13 years, mislabeled, misunderstood, and completely unremarkable to anyone who looked at it. When the correct classification finally arrived, quasar, 10.8 billion light-years away, the most massive black hole currently known to science, the smudge did not change. The plate did not change. Only the question changed. 70 years later, the question is still changing.